4.1 to 4.3, differentiation. First, let's learn the definition of a derivative. Charlie, if this is f of x, find the definition of the derivative. What do you do first?
First, you plug x plus delta x into that function.
Go ahead and do it.
Next,
Perfect.
you write f of x.
Delta x plus delta x squared plus 2.
X squared plus 2.
Is that in parentheses or not?
Yeah, it is. Okay.
See, children, that's a common mistake that you might make, so make sure parentheses are a parenthesis must.
Oh my god. All over delta x.
Perfect.
Then x squared and the 2 can cancel out.
Whoa, what do you know?
Math. Then you're left with 2x delta x plus delta x squared all over delta x.
But Carly,
Then
where do you go from there?
you cancel out the delta x, Maddie.
Oh, whoa.
Cancel, 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 and your final answer is 2x plus delta x.
Is that in a box?
It is in a box.
That is in a box. Now that Carly has shown you how to do the definition of a derivative,
You're welcome.
it's your turn. Do example number 1. Do 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 Alright, time for you to check your answers. See if you got it right. 2x we found in the example problem is the slope at any given x coordinate. Isn't that right, Carlin?
Yeah. Carlin.
Now, class, is the function differentiable at all points along this line?
No.
Correct! It is not differentiable at x equals 0. Do you know why?
Because it's a sharp point.
It is a sharp curve, Carly. Very good observation. And when it's a sharp curve, the slope of the tangent line is a vertical line. Now, Carly, what is the slope of a vertical line?
Undefined.
Very good. So, if the slope of the tangent line is undefined, well then the slope of this point is also undefined, making this function not entirely differentiable. But Carly, does that have anything to do with it being continuous?
Yes. No.
Very good.
No.
It is still continuous because there are no jumps or holes or any sort of funky things that can happen with graphs. So although it is continuous, that does not necessarily mean it is differentiable at all points. But you gotta be thinking, isn't there an easier way to find the derivative than this? Well, sure. We remember learning that. Derivative of x to the n is n times x raised to the n minus 1.
Now, let's take a look at the product rule. When trying to find f of x equals ab, the derivative, you do... Get down. f of x equals ab prime plus ba prime. For example, f of x equals x cubed 5x squared. We start by taking a, x cubed, and b, 5x squared. Then we get x cubed times 10x plus 5x squared times 3x squared. And our final derivative equals final derivative equals 25x to the 4th.
Class, time for you to do example number 2. Yeah. All right, check your answers. Is it right? If so, good job.
Your mom!
If not, always room for practice.
Whoa there, Nellie. How do you do this problem? Don't worry. We have a nifty little jingle to teach you.
Lo di high minus high di low. Draw a line square below.
And as low D high, the D part stands for derivative. Okay. Ejemplo, 5x squared over x cubed. You solve it out by doing the nifty little jingle.
Lo di high minus high di low. Draw a line square below.
And your final answer comes out to be negative 5 over x squared.
Class, you know what to do this time. Time for example number 3. Do 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 Did you do it right? Let's hope so. Now we're going to put all our knowledge of differentiation and such to practical use. Carly, kindly throw the ball. Perfect. Hey, Carly, do you know how high the ball went?
Yeah, 10 feet.
How do you know that?
From the original function.
Wow. Do you know how fast it was going?
No, but you can find the velocity with the derivative.
Wow. Do you know how much it accelerated?
No, but you could also find that with the second derivative.
What's
Also known as the derivative of the derivative.
Oh, derivativeception.
Hey.
There's Maddie and Carly signing out. You say classy. Period 1.
San Diego.
Period 1 works.
San Diego too should say classy.
No.
You shouldn't be unclassy
No.
if you're in San Diego or period.